What do we got? How do we calculate that probability? Probability that you got through. Now, what's the probability? What are we talking about? P is the probability of what? Success, which is the probability of going through the lights. What's that probability? 0.3. So you go through no sets of lights. So what's your probability? 0.7, by 0.7, by 0.7, by 0.7. Don't want to really talk about that as such. I want to talk about there's 4 lights, you go through 0. And what we're looking for, success, is 0.3. So the chance of getting through a set of lights is 0.3, and we got through none. What does that mean? 0.7 happened to us 4 times. So there was no lights we went through, and there were 4 lights that we got stuck at. Am I correct on my numbers? I got them the right way. Next one, 4C1. This time, I got through 1 set of lights, but there were 3 sets of lights that I didn't get through. So yesterday you looked at this and a lot of you went, not really. 4C2. So what's this 4C2 about? So if you talked about, here's the first set of lights, here's the second set of lights, here's the third set of lights, here's the fourth set of lights. You ready for it? I got through the first and the second, because I didn't get through the third and the fourth. I got through the first and the third. I didn't get through the second and the fourth. I could cross them, but I'm not going to. I'm going to save the effort. I got through the first set of lights, I got through the fourth set of lights. So on my way to work, I could have got that happening. What else could I get happening? I could get through the second set of lights and the third, if it was 2. So if I said to you, over the last few weeks, a lot of times I've gotten through 2 sets of lights. How many ways could I get through 2 sets of lights out of 4? So then I can get through the second set of lights and the fourth set of lights. So we finished all the first with the second, third and fourth. We finished the second, we didn't get through the first with the third and the fourth. And the last one is, we get through the third and fourth. How many ways have I done it? 1, 2, 3, 4, 5, 6. How many of those were there? 6. How do I get that 6 without going through this process and 3 diagrams? 4C2. Now for those who are in spec, they know what 4C2 is and how to calculate it. So what have I got? I went through 2 sets of lights. Now is it in your head that 0.3 is going through the lights? So that means there was 2 lights that I didn't go through. This one here, 4C3, I went through 3 sets of lights and I didn't go through 1 set of lights. And the last one, 4C4, and I went through all 4 sets of lights and I didn't go through that set of lights. This concept written like that is important later on, okay? For one particular case of questions they like to give you. So how do we do that? Can you pick up your calculators, please, your class pads? Can you all do it?
Yeah, it's already given me 6 though.
6,
so
that's that number there. That means that out of all the sets of lights I'm going through, you got to remember there's 6 ways that I can go through 2 lights of green or go through. So then you got to add the probability to it. Okay, let's slow down with you, mate. Let's call them green and red. Let's say we had green, green, red and red. So green meaning you did go through legally, and red meaning you didn't go through legally. Because you'll see people zoom through illegally. You ready for it?
Yeah.
What's the chance of green?
I don't know.
0.3 from my observations. What's the chance of the next one being green? 0.3. Do you see how idealistic this is? Because even if a set of lights is 0.3, it doesn't mean it's 0.3 every time. Depends on the traffic, and it also depends on if people are not turning in the opposite turning lane and you get a longer go. But we're getting an idea of the probabilities of what could happen. Real life probability. What's the chance of it being red?
0.7.
What's the chance of being 0.7? Point red. Point red. What's the chance of being red?
0.7 again.
0.7. So what have I got? I've got 0.3 squared times by 0.7 squared. So go back to here. I got 0.3 squared and 0.7 squared. But how many ways could you do that? 6. Because that was green, green, red, red. What about green, red, green, red? What about red, green, red, green? What about red, red, green, green? You right?
Yeah.
So all of those ones will all have the same calculation like that. And then you've got to say how many ways, and the number of ways is 4C2. But if you don't want to think about 4C2, you can just go the number of ways is 6 and work it out yourself. What's interesting for me with this, I go through about 4 sets of lights. I think I go through 4. And you know, some days I'm driving to work and I get through all 4. And I go, how common would that be? And sometimes I'm driving to work and I'm in a hurry. I want to do some things before your class starts. And I get 4 red lights. And I can go through this and go, well, how likely was that? Now, for the rest of your days, you guys will be driving somewhere, and I've got my oldest daughter who says to me, Dad, the lights turn red on me all the time. And I'm in the car with her and I said, that one was green. And the next one was red, and the next one was red, and the next one was red. And I go, that one was green. She's majoring on the fact that she's got all those red lights. The fact is, how many did she expect to get through? Probably 1 out of 3 or 1 in 4. Maybe 1 in 5. So you get a job, you're driving to work. From my experience, that's a pretty reasonable number. It might be 0.25, might be 0.27, it could be whatever it is. And you've got 4 sets of lights, and for the rest of your days, you'll know that you'll only get 4, what's this about? This is 4, is it 4 red lights or 4 green lights? No green, so 4 red. So about 1 out of 4 days you're expecting to get red, 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 red. So about once a week you're going to get all red lights. How often are you going to get all green lights? 8 out of 1,000. Say, let's do rough figures. 8 out of 1,000, which is about 4 out of 500, which is about 2 out of 250, 1 out of 125. So if you drive to work 5 times a week, how often do you expect to see green, 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 green?
Once every 5 weeks.
Once every 25 weeks. Now, how do you get EX? I get you guys to do the figures from me. EX is the? What is EX? Yeah, it's the expected value. What do we call it in real life? What do we refer to it as? Average. Which you can refer to as the mean, which you can refer to as X bar, and on our formula sheet refers to it as mu. How do you calculate it? The sum of each of the X values times by each of the probabilities. And here's what you're going to do. 0 times 0.2401. You need to type that in. 0 times something is 0. 1 times 0.4116. 2 times 0.2646. And this is the moment coming, Liam, that I want you guys to sink in with. Turns out to be 1.2. You ready for it? If you multiply n times p, what's n stand for? How many sets of lights am I talking? Number? How many lights am I talking about? 4. What's the probability of getting through 1 set of lights? 0.3, 1.2. The mean can be calculated that way. And if we're doing binomial probabilities, only for binomial probabilities. And what makes a binomial binomial? No negative probabilities. The probabilities stay the same. They're independent of each other. 0.3, 0.3, 0.3, 0.3. So when I'm driving to work, is it really 0.3, 0.3, 0.3, 0.3? No. It might be 0.29, 0.38, 0.4, 0.26, point whatever. But it's too complicated to do it that way. So which way am I going to do it? They're about 0.3. Gives me an idea of how frustrated I get that I don't get through 4 green lights more often. Yeah? Get the point? It's just NP. Major formula. Now let's get the variance of X. And of course I'm going to be cruel to you and make you do it all the long way. And I'm going to give you a similarly simple formula. And a lot of people just don't remember that formula. Or go, why is that formula true? Ready? How do you do it? You get the sum of the probabilities and x minus x bar squared. And what's that called? The deviations. Each probability. So what's the first probability? 0.2401 multiplied by bracket. That score is 0. What was the average? 1.2 squared. What do you do next? That was using x equals 0. And you've got to add to it. The next probability, 0.4116 times by this time 1 minus the average squared. Yes, questions? Now any of you are okay. Can you finish on that for a sec?
How is 1.2 the average when it's bigger than all the numbers?
Oh, okay. How many lights do I expect to get through every day? 1.2. How many traffic lights am I heading through? 4. So I'm expecting to get through 1.2 sets of lights per day.
I thought they used the average of the Y values.
Yeah, nah. So 4 sets of lights. EX is how many lights I expect to get through each day. So by the way, some days I'll get through 1, of course. Some days I'll get through 2. Occasionally I'll get through none. Occasionally I'll get through 3. And rarely I'll get through 4. So it's an average of how many lights. So in other words, I could record for the next 100 days how many lights I got through. Yeah? So for this morning I got through 2. No, actually I think I got through 3 this morning. So I go tick for 3. Like rolling a dice. You know how we said the long-term average of the dice? So the expected value for the dice 1, 2, 3, 4, 5, 6 is 3.5. So it's not the probabilities. It's the average that we're expecting to get long-term. So if I keep rolling the dice, on average I'll get 3.5. Has anyone done it for us? What have we got? P. We got the 2. No, it's not 2, is it? What's the formula? That probability times by that number minus the average. Turns out to be 0.84. All those yucky numbers turns out to be a nice number. Anyone want to have a guess at the formula for the variance using binomial probability? Where the probabilities supposedly are staying the same and they're independent of each other. Probability stays the same and they're independent of each other. Does one set of lights have an effect on the second set of lights? No. You ready for it? Same formula as you just had a moment ago. I multiply it by. Now I'm going to write Q. Or you can write that as NP times by 1 minus P. Q is 1 minus P. P was 0.3. Q is 0.7. And what's the answer we get? So how many this time? 4 sets of lights. Probably getting through is 0.3. Probably not getting through is 0.7. And the answer is 0.84. You go, woohoo! I can just go NPQ. Impressive? Come on, give me a half grin or smile. I go, come on. So how do they get standard deviation? Square root of 0.484. And when someone said to me, could this be in the non-calc section, I had nice numbers in my head. That worked out really nice. I've got them written down in the back of my textbook, I think. So I could give this to you in the non-calc section.